In this video, we will learn about latent heat. Now, we know that during the phase change of a substance, that is from liquid to gas, or from gas to liquid, or from solid to liquid, or liquid to solid, or solid to gas, or gas to solid, we need energy. It is either absorbed or released. Okay. Now, if a solid want to get converted into liquid, then during this transition, heat is absorbed. Okay, heat is absorbed. And if a liquid wants to go into a solid state, then it has to release the heat energy, right? Now, so we can say that heat energy is absorbed during melting process and it is released by a liquid during freezing process. Although there is no change in the temperature either during the melting or freezing processes. Now again, for liquid gas phase change, heat is absorbed by a liquid during the vaporization and heat is released by a vapor during condensation without showing any change in the temperature. Now, heat energy is absorbed or released by a substance during its phase change. It's called the latent heat. Okay, because it is not externally manifested by any rise or fall in the temperature because the temperature remain constant. So the heat which is rejected or which is accepted, or we can say the heat which is released or absorbed during the process of phase change without hampering the temperature, which is temperature will remain constant, is known as latent heat. Now, molecular theory for latent heat of melting. We know that the total energy of molecules of a substance is the sum of their kinetic energies and potential energies. In a solid, molecules can have only vibratory motion, and vibrational kinetic energy of molecule is directly proportional to the temperature of the substance. Okay, since during the process of melting the temperature will remain unchanged, so we can say that there is no change in the kinetic energy of the molecules. Let us suppose you have a solid object like this. Now there are molecules arranged in it like this. Now these molecules are attracted towards each other, forming a bond which is known as the intermolecular attractive forces. Okay, now this heat supplied, that is this latent heat supplied, is responsible for breaking these intermolecular attractive forces between the molecules. As a result, in liquid phase, molecules are loosely bound as compared to solid state because the latent heat provided these molecules so that they can break their intermolecular force of attraction. Okay, now thus we can say that the latent heat supplied during the melting of a solid is used up to increase the potential energy of the molecules by doing work against the intermolecular attractive forces. Now, specific latent heat. So it is the amount of heat energy which is absorbed or released by unit mass of a substance during its complete phase change without any change in the temperature is known as specific latent heat of substance. Now we already know the latent heat definition. So if we use this definition for a single gram or for a unit mass, let's say unit kilogram, anything, we use the word specific. Okay. Now it is denoted by letter L. Now, if m is the mass of the substance, it absorbs q heat or releases q heat. Okay, then for the change of state without any change in temperature, specific heat or specific latent heat would be the heat absorbed divided by the mass, or we can say the heat released divided by the mass of the substance. Or we can write heat absorbed or released is given by mass into specific latent heat. Okay, now you have to learn the specific latent heat for water into gas form and ice into water form as well. Okay, now there are two types of specific latent heat. First is specific latent heat of fusion, denoted by letter LF. So it is the amount of heat absorbed by a unit mass of given solid, let's say ice 1 gram getting converted into water 1 gram. So the amount of heat energy required here is known as latent heat of fusion, or I can say the specific latent heat of fusion without any change in temperature. Or I can say the amount of heat energy released by a unit mass of liquid to get converted into ice. Let's say water is the liquid, ice is the solid part. So a liquid getting converted into solid unit mass requires latent heat of fusion amount of heat or specific latent heat of fusion amount of heat to get changed into solid. Okay. Now, specific latent heat of vaporization. So It is the amount of heat energy which is absorbed by unit mass of a given liquid for complete conversion into vapor form. So if it is a liquid, now it want to get converted into vapor. Like for 1 gram of this, we use specific latent heat of vaporization, which is LV amount of heat. Okay, without changing in temperature. Similarly, heat released when unit mass of vapor condenses to form liquid without any change in the temperature. I hope this topic is clear to you. Thank you.